Alright, so we have concept C, quadrilaterals in the coordinate plane. And we're going to scroll down to the example. Now, please read through all of this. I'm not saying just skip to the examples because there's a lot more information through here than I am providing. I am providing the examples based on the assumption you have gone through this entire lesson and you have watched the additional video that has been provided. So I am only providing videos on the examples because they're a lot similar to, bad grammar, I apologize. They're very similar to the projects that come at the end of these lessons. And so I wanted to provide you with some clarity as we worked through the examples. So, example. Prove that a quadrilateral is a rectangle using the distance formula. Okay, and I'm going to remember back that the distance formula comes from the Pythagorean theorem. So I am only going to remember the Pythagorean theorem, which is a squared plus b squared equals c squared, where c is our hypotenuse, and I did not draw that. Okay, so Drea wrote the following proof based on the given information. Given that a quadrilateral ABCD with vertices A at negative 4, 3, B 4, 3, C 4, negative 2, and D at negative 4, negative 2, prove that the ABCD is a rectangle. Okay, here is a paragraph proof. So I can use the distance formula and the given coordinates A negative 4, 3, B 4, 3, C 4, negative 2, and D negative 4, negative 2 to find the lengths of the diagonals. And then it is showing her work using the distance formula. AC equals the square root of the quantity 4 minus negative 4 parentheses squared plus the quantity of negative 2 minus 3 squared is approximately 9.43. BD is equal to the square root of the quantity 4 minus 4 squared plus the quantity 3 minus 2 squared equals 1. Because BD does not equal AC, the diagonals are not congruent. Therefore, ABCD is not a rectangle. Okay, before we move on, the first thing I always like to do when I am looking at a proof is to work through it myself and see if I agree with them. So I'm going to set this up as how I would do it. So I'm looking at a quadrilateral ABCD. I'm going to draw a rough sketch of the vertices. So negative 4 up 3. That's A. B is at positive 4, 3. So over 4 up 3. C is at positive 4, negative 2. And D is at negative 4, negative 2. Okay, so roughly it looks like a quadrilateral. I'm going to use a hint here, and it's finding the lengths of the diagonals. So, was she right in connecting our diagonals? AC, yes, that is a diagonal. BD, yes, that is a diagonal. So, we will show our work to find AC. So, AC is equal to the square root. So first I'm going to look at these vertices A and C, and pick one as the first point. So A, x1, y1, C, x2, y2, and then we're going to use the distance formula, which is from the Pythagorean theorem. Okay, so we have the square root of, I want to know the horizontal distance, so that is why they take x2 and subtract x1 is to find the horizontal distance. So I take 4, subtract a -4 squared plus, okay, now they want to find the vertical distance. So that's why they take y2 and subtract y1. It's finding a distance. -2 minus 3. And that quantity is squared. So then I'm going to come over here and click on our graph, and I am just going to type in parentheses 4 minus parentheses -4, and that's going to be squared plus parentheses -2 minus 3 parentheses, and that quantity is squared. That's why I say quantity, is because that means it's what's inside the parentheses. That is coming out to equal 89. So then I know that this is equal to the square root of 89. So then I'm going to come back over here, type in the square root of 89, 9.433, which is what she found. So yes, that one I'm agreeing with so far. So then now let's find BD. So then we're going to pick BD, and I'm going to say B is x1, y1, and D is our x2, y2. So then we have BD is equal to the square root. We're finding the horizontal distance, so that's why they take our x2 and subtract x1. It's the distance formula on a number line for just the horizontal axis. So we have x2, which is -4, minus x1, 4, quantity squared, plus, now I want our vertical distance right here. So that is using y2 minus y1. That's why we're finding that, is because it's the distance. So y2 is -2, minus 3, quantity squared. So then I'm going to click on my calculator again, type in parentheses -4 minus 4 parentheses squared plus parentheses -2 minus 3 parentheses quantity squared. That's going to equal 89. That is familiar. And the square root of 89, Okay, so this comes out to be